Hello guys, I want to take you through one of the interesting topic which is called Euclidean geometry, and we'll be looking at some theorems of Euclidean geometry. For you to be very good in Euclidean geometry, you seriously need to know your theorems. So, okay, so there is this theorem: a line drawn from the center of a circle perpendicular to chord bisect the chord. What are we talking about here? Let's say we have got a circle and we've got the center of a circle. So we are saying a line drawn from the center of a circle, the line will be coming from the center. In this case, I have this line. Let's say we have center O. Let's say our center is center O, and the line is coming from this and the line is coming from the center of a circle. And let's say we also have the chord AB. A chord is a straight line from one end of the circumference to the other. So let me say I have a straight line. Yes, it should be a straight line, guys. So here we're talking about a line from the center. So you can see this line is coming from the center and is going to the chord, and the line is perpendicular to chord. So this line, which comes from the center, going to the chord and being perpendicular to chord, will bisect the chord, meaning that will divide the chord equally. So we'll say this part of the chord equals to this part of the chord. So let me just put here M. So therefore we say AM equals to MB. What makes AM to be equals to MB is because of a line which is coming from the center of a circle and it's also perpendicular to the chord. Line comes from the center, it's going to the chord and is perpendicular to the chord. That line divides the chord equally. So let's say we have got a circle again, and we have got the center of a circle. Let's call the center, in this case, let's say the center is M. So we've got the center, and let's say we still have a chord, which is what? AB. Let's say we have a line from the center and it's going to the chord, but that line, let's say, is not perpendicular. Let's say this line is not perpendicular. Maybe it's 60 degrees. It's not perpendicular to the chord. So we cannot say this line divides the chord equally. No. The line which is coming from the center going to the chord, for the line to divide the chord equally, that line has to be perpendicular. The line has to be coming from the center and the line has to be perpendicular. So, guys, if we have a circle and we have a chord of a circle, which is what? C, in this case, let me say we've got CD. You have to remember that the chord CD can be divided equally. What divides the chord equally? It's a line that comes from the center, and that line should also be perpendicular. So let's say we have a center here. Let me call the center in this case W. So if the line is coming from the center and is going to this chord, the line is coming from the center, it's going to the chord. If this line is perpendicular, meaning that they form 90 degrees, it means that this chord will be divided equally. So you know that the distance from this point to C, hoping you see the point. Yes, this point to C is the same as distance from this point, the same point, to D. So the chord can be divided equally. And once divide the chord equally, it's a line that comes from the center, and that line also has to be perpendicular to the chord. If it's not perpendicular to the chord, cannot divide the chord equally. Hoping you understand this theorem. Let me make sure that you understood this theorem. uh, that says a line from the center of a circle to the chord perpendicular to chord bisect the chord. What's happening? I want to pick an eraser. Okay, something is wrong, but it's fine. Let me create another circle here. Let's say you have a circle. Oops, this is an ugly circle. Ignore this part. This is a circle, and we have the center of a circle. Let's say we have a chord. In this case, a chord is, let's call it what? EF. You know why it is a chord? Because it's a line from one end of the circumference to the other end of the circumference. It's a straight line. So it's a chord EF. So let's say EF is equals to 8 centimeter. I'm saying this, the distance from E to F, the length of the chord, it's 8 centimeter. And let's say we have a line coming from the center of a circle and going to the chord. Remember, this line which comes from the center going to the chord can divide the chord equally if that line is perpendicular. So I'm putting 90 degrees here to say, this line, let me call it OM, the line OM. The line OM is perpendicular to EF, and the line comes from the center, so the line will divide the chord equally. Take that into account. And let's say you have OE, which is, in this case, we know that OE, oops, why? This OE is a radius because it's a line from the center of a circle to the circumference. So a straight line from the center to the circumference is a radius. And let's say this OE, my radius, let's say my radius is, what can be the radius? The radius is a longer line, so let me say the radius is 5. Let's say the radius is 5 centimeter. And I want you to determine OM. I want you to find the length of OM. Okay, let's look at it. Let's look at the diagram. You have a circle centered at O. You have the chord EF. You have the radius OE, and you have the length of a radius OE. It's 5. So you can come. Is it possible to pick? I wanted to change the color, but it's fine. Let's keep red. OE, the length of OE, it's 5 centimeter. And what is the, you want OM, but you know EM. You know the length of EM. Why? Because EM is equals to MF. The length of EF was 8, so EM should be 4 centimeter because EF is being divided equally. It means EM is 4 and MF is also 4. You still remember that theorem? Line from the center of a circle to the chord perpendicular to chord bisect the chord. So you have to find OM. You now have to use the theorem of Pythagoras. You have to know that this angle M, this side also is 90 degrees, angles on a straight line. So now you see that the triangle OME is a right angle triangle. OME is a right angle triangle. So for you to calculate OM, you have to use the theorem of Pythagoras. Remember, the theorem of Pythagoras is used only in a right angle triangle. So OE, which is my hypotenuse, OE squared, this is how I apply the theorem of Pythagoras. I always start with a longer side. That longer side is the hypotenuse. So you say OE squared, you say the hypotenuse squared, OE squared equals to EM squared. You can come in. EM squared. I'm coming. Give me 2 minutes. EM squared plus OM squared. So we are applying what? The theorem of Pythagoras. OE is the hypotenuse of the right angle triangle OME because, okay, yeah, it's the hypotenuse. It's the longest side of a triangle. So OE is 5. So you say 5 squared. This keeps disturbing me. You say 5 squared equals to EM 4 squared OM squared. We are looking for OM. 5 squared 25, 4 squared 16, OM squared. You take 16 to the other side, so you have 25 minus 16, which is 9 now. 9 equals to OM squared. You put the square root both sides, so you should have OM equals to plus or minus square root of 9, which is plus or minus 3. So, but we know that the distance can never be negative. So, the length of OM is 3 centimeter. We cannot say the length is negative. So, this is how we found the length of OM. The theorem which was important is the theorem that says the line drawn from the center of a circle perpendicular to chord bisect the chord. So hopefully we understand the theorem and how we can make use of the theorem. But for grade 12 purpose, you have to remember that we are actually required also to prove the theorem. I'll show you how to prove the theorem. Something is wrong with I wanted to erase everything and then prove the theorem. Something is not going well. Let me end the show. Discard. Okay, let me from the current slide. Okay, we are still on this theorem. I want to prove this theorem. That says if let's say we have AB, this is O. Guys, I have to stop here. I have to go and attend some other guys. So I just have to stop here. I'll show you how to prove this theorem. Sure, you can come in. I'm coming. Oh, sorry. I'm coming now. Let me